Welcome to Section 5.1, Greatest Common Factors and Factoring by Grouping. So here's a question. Suppose Keiko has straight hair and glasses. Jack has curly hair, glasses, and a hat, and Layla has glasses and straight hair. What do they share in common? Well, let me just go ahead, for fun. Let's go ahead and draw out our characters. Just the top portion. I won't do the legs. Okay, so we have Keiko, Jack, and Layla. And what do we know? Keiko has straight hair. Okay, so I'll just go ahead and draw some little straight hair coming down. No bangs, I guess. And glasses. I'll go ahead and do those in blue. Jack has curly hair. I'll go ahead and give him some Ronald McDonald or maybe Ronald Weasley hair. Okay, he has curly hair. What else? Glasses again. And a hat. Okay, let's draw the hat. My baseball cap hat. And then, what do we have? And Layla has glasses, okay. And straight hair as well. I'll go ahead and give her blonde hair, why not? Okay, so what do they share in common? Well, when we look at all of these are individual groups, right? These are each individuals, and what do they share in common? Well, they don't have the same hair, and only one of them has a hat, but they all have glasses. So the greatest common factor that they share in common, in this case, the greatest common factor would be that they have glasses. And this sort of concept is how we would look at the terms in a math problem. If we had a term like 3x squared plus 2xy minus 3x, we treated them as terms, individuals, and we looked at them and said, what do they all have in common? There are things that they don't have in common, but you'll notice they each have at least one x. So that's kind of how we're going to look at this. Example 1, factor out the greatest common factor. So sometimes you're able to just visualize the greatest common factor, but other times some students, I found, need to actually factor each term. So I'm going to go ahead and factor each term. So 9z, this is not in the primes. So I want to split 9 into the prime numbers. And remember, the prime numbers are numbers that cannot be split down further. So for example, 1, 2, 3, these guys are all not divisible by other numbers. And so on. There are other prime numbers. So 9. Well, 9 can be rewritten as 3 times 3, right? And then we still have that z. We'll bring down the minus sign. And then what can 18 be written as? 18, let's do this on the side, 18 is 2 times 9, but we can still break down the 9, right? We can break that down into 3 times 3. So 18 can be split into 2 times 3 times 3. So we have these two terms, and we're trying to figure out the greatest common factor in these terms. What do they share in common? Well, they each have 1 3. Actually, they each have 2 3s. Okay, so since they each have 2 3s, we can bring out those 2 3s. And what is left over? Well, since those 2 3s are gone, we're left with a z. And since these 2 3s are gone, we're left with that 2. So bring down the negative and the 2. And then finally, to simplify, the 3 times 3 is a 9, z minus 2. And that would be our answer. So you don't need to show the work for this factoring part. If you're able to do that in your head when you factor out your work, that's perfectly fine. This would be the final answer. However, if the factoring helps you, go ahead and do that. It's good to show as much work as you can. So let's take a look at this next one. This one's a lot more complicated. So the first term, let's go ahead and factor that. Well, let's see, 32 is 2 times what? Let's see, 2 can go into 32, 1 minus 2, 12, 16. So 2 can go into 32 16 times. But 16 is not prime, that's 2 times 8. 8 is also 2 times 4. And 4 is 2 times 2. So 32 can be rewritten into 2 times 2 times 2 times 2 times 2. Wow, that's a lot of 2's. So let's go ahead and write that down. Let me actually block off the area so we can work on the problem. So this is going to equal 2 times 2 times 2 times 2 times 2. There are 5 2's. And then we have the p's. 1, 2, 3, 4 p's, and then 1 y. Minus. All right, what do we have next? Well, the 24. What can the 24 be pared down to? 24 is 2 times 12. 12 is 2 times 6. 6 is still factorable, so that's 2 times 3. So we know that 24 can be written into 2 times 2 times 2 times 3. So minus 2 times 2 times 2 times 3. And then we have 1, 2, 3 p's and a y. And that comes from the p to the third power and the y. Alright, and then, we're kind of running out of space. Once again, the step that I'm showing here with writing it all out, you do not need to do that. I'm just writing it out so you can see all the factors. So I'm going to go ahead and write the next one below, but 40 is the same as 2 times 10. Sorry, 4 times 10. And then 4 is 2 times 2, and 10 is 2 times 5. So 40 can be rewritten into 2 times 2 times 2 times 5. So we have 40 is... Actually, let me rewrite this. I want to have enough room. Three times 3, p times p times p times y, plus, and then we have, so the 2 times 2 times 2 times 5, 2 times 2 times 2 times 5, and then p to the 5th. 1, 2, 3, 4, and 5. I'm going to squish that on. Okay. Once again, do not need to show this step. So, in all of these groups, we have the 3 different terms. We have this term here, this term here, and this term last. They are all been perfectly factored. Now we're asking ourselves, what do they have in common? Well, they all have 3 2's. And they also all have 3 p's. Other than that, though, there's nothing else in common. Okay, so that's all that they have that we can pull out. So, let's go ahead and take out the 3 p's from, or sorry, the 3 2's from each of them. So I'm going to go ahead and rewrite that as 2 to the third power, because there are 3 2's. And then we're going to pull out the 3 p's from each term. So I'll rewrite that as p to the third power. Okay, so once we've factored it out, we're going to go ahead and write our multiplication symbol. And what's left over? We have the 2 times 2 and the p times y. So 2 times 2 is 4 py. Bring down the minus sign, minus. Then we have the 3y left. And then plus and 5 pp. Or p squared, because there were 2 p's left. Okay, and there we go. We're done. We have pulled out the greatest common factor. Last thing we should do, actually, because I know what 2 cubed is, that's 8. So go ahead and rewrite that out. 4py minus 3y plus 5p squared. Now you might say, what if it was 2 to the 4th power or something? Would I have to rewrite it into the actual multiplied out? The answer is, anything to the 3rd power, I would usually say you should multiply it out unless it's bigger than 10. Okay? Other than that, though, yeah. Always try to multiply it out if it's to the 3rd power. Unless it's bigger than 10. Alright, so that's that for that. Okay, let's take a look at C. So this time, I'm not going to write out all that intermittent middle work like I did before. Let's see. In 15z squared, that's the first term, and then the other one is 5z m plus n. Actually, you know what? I am going to rewrite it out into the factored. So 15 can be rewritten as 3 times 5. And then we have z times z, because there are 2 z's. And then m plus n. That's the first term. I'll bring down that plus sign. Then we have 5 times z times n plus n. Ooh, but there are 2 of them. Times m plus n. So now, looking at the 2 terms, this first term and the second term, once again, terms are separated by plus or minus signs. What do they have in common? Well, they both have a 5, and they both have 1 m plus n. And we can only take out the same thing, or the same amount from each one. So we'll pull out the 5's, factor out the 5. Once again, we're factoring out the 5. And then we'll factor out the m plus n. And what is left over? Well, we have the 3 and the z squared. Ooh, I just realized they both have a z. There's that z and there's that z. So we can go ahead and bring out that z because they share a z in common as well. I almost forgot that. Okay, always good to check your work. All right, so let's go ahead, put down that z. And then what's left over? 3z plus m plus n. And let's simplify that out. So that's 5z times m plus n times 3z plus m plus n. Now you might say, hey, look, they're being multiplied. I should start multiplying this out. The answer is no. That would be defeating the purpose. So remember, factored, you should write them out so that it's a bunch of multiplication problems. That's when it's factored. Okay, so factored means you have different things being multiplied together. All right. So example 2, factor the 4-term polynomial by grouping. Okay, so whenever you have 4 terms, let's see, we have 1, 2, 3, 4. Okay, good. 1, 2, 3, 4. The best way to factor 4 terms is by grouping, and usually you group them so you have 2 terms grouped with another term. So let's go ahead and do that. So most of the problems in this course are set up so you don't have to rearrange the different numbers to try and group them. They're usually already given to you in the way you're going to group them. Before we continue though, there is a small typo. This should be ax minus ay plus bx minus by. Okay, so for grouping, usually you're going to group the first and second term together and then the third and fourth term together. And for this course, that's basically the way you'll do it. Sometimes you do have to switch the terms around, as I mentioned, but usually not in this course. All right, so focusing on the different terms, we have the first group and the second group. Now let's focus on each group separately. So in the first group, the blue group, what do they share in common? Well, they both have an a. Let's go ahead and factor out that a. And then what's left over? X minus y. We'll bring down the plus sign. And then in the second grouping, what do they share in common? They both have that b. So we'll factor out that b, and then what's left? X minus y. All right, so now, what have we created? Well, we have created something that is only 2 terms. So now we have a new first term. So this is our first term, and we have a second term. Now looking at these two, do they have anything in common? Yes, they both share an x minus y. So we'll go ahead and factor out the x minus y. So x minus y. And then what's left over? Well, what's left over is the a plus the b. And there we factored. We have factored by grouping. All right, so let's take a look at the next one. Now, we have to be careful whenever we see minus signs when we're doing grouping, and I'll tell you why. So I'm going to go ahead first, I'll write this down again for my grouping. So I'll group the first 2 together, and I'm going to group the second 2 in a way that's considered incorrect, and I'll show you why in a second. So let's say I don't change anything. I just immediately, put in the grouping symbols. If I was to take that negative that's in the middle and distribute it back in, my question to you is, would I get the same thing as what I had started with? Well, that would give me a negative 4q squared minus 10p squared. Notice, originally, that was a plus sign for the 10 squared. But when I factor it that way, I have a minus sign. So, this is because we've created parentheses, and we have to be careful about the distribution property that comes with parentheses. So in order to keep that from happening, we have to sort of change our problem a little bit. So once I introduce the parentheses, and I put that minus sign in the middle that was already there, what I'm going to do is I have to change the next sign. Change it to the exact opposite. What's the opposite of a plus sign? it should be a minus sign. So we're going to go ahead, swap that to a minus sign because we put in the parentheses, and then we're good to go. So that's the main difference. Whenever you're working with a negative that is in the middle, you need to remember to change the sign of the last term. All right, that's something that often catches students. All right, so let's see. You know what's something I forgot to do? I forgot to simplify the problem before we started. Let me go ahead and back up. Whenever we start a problem, we want to simplify it as much as possible. Now, do you see if these share anything in common? Yeah, they all have a 2 that we could take out of them. So, I'm going to go ahead and factor out that 2. And then what do we have left? Minus 10 minus 2q squared plus 5p squared. Okay, so we factored out that 2. Now let's go ahead and focus once again on the 4 terms inside the grouping here. If I was to group these first 2 together, and then group the second 2 together as we were doing previously, we might run into a problem. Notice, these 2 don't share anything in common. That 10 does not have a p or a q. And then, these 2 here, they don't share anything in common either. So that grouping doesn't sound like a good idea. So now we run into that one time, which is unusual in this course, where we do have to switch around the terms. So I'm going to go ahead and pair off the 2q squared with the p squared q squared, because they both have a q. Which then means I'll pair the 10 with the 5p squared. Okay, so once again, what am I doing? I am rearranging things. So I'm going to go ahead and pair the 2, the negative 2 squared, or the negative 2q squared, and then pair the 5p squared and the 10. Okay, so when I rearrange it like this, I no longer have a negative sign in the middle of my terms, so I don't really have to worry about that switching signs thing. So then we have 2, and let me go ahead and group. So we have p squared q squared minus 2q squared, bring down that plus sign, and then 5p squared minus 10. Okay, so now I have finally done the grouping. I had to do some rearranging. How did we know how to rearrange? Find the terms that have similar items in them. So in the first grouping, what do they have in common? Well, they both have a q squared. So let's go ahead and factor that out. So once again, bring down that 2 from the outside. And then we're going to factor out the q squared. And then what's left is p squared minus 2. Plus, now let's take a look at the next grouping. In the next grouping, what do they have in common? Well, they both have a 5. There's a 5 here, and then inside of 10 we know there's a 5. So let's go ahead and factor out the 5. And what's left over is p squared minus, remember 10 is 2 times 5. So we have 2 left over. All right, we're almost done. Now we have created a binomial. We have 2 terms. We have the first term and the second term. Do they share anything in common? They do. They both have a p squared minus 2. So let's go ahead and factor out that p squared minus 2, bringing down that first 2. So factoring out the p squared minus 2, what's left? The q squared plus 5. And that is it. We're done. Alrighty, that is it for this section. Once again, if you see 4 terms, group them for factoring, and then always make sure to factor out a common factor first so that your problem is simpler. If you have any questions on any of this process, please stop by my office hours.